Welcome back, folks. I promised you an example of calculating powers with passive sign conventions. This one's going to make you think a little bit. Sorry. It's my job is to induce thinking. And we're going to try to do a little bit of that today. I have a circuit ready for you. It's something that we're going to revisit because I filled in some values, knowing some of the other fundamental laws. We'll revisit it when you can fill in those fundamental values. But for now, I want to look at just conservation of energy, conservation of power, as it relates to the passive sign convention and how we calculate power in circuit elements. Okay, so here it is for you. I filled in the bits that we're missing. We have voltages and currents for every single component up here. So I see 3 resistors and I see 3 independent current sources. We've got to calculate the power for all 6 things. Now, if we're truly conserving energy, then we're going to be able to sum all of these, and hopefully, if we do it right, come on, it's all going to sum to 0. Okay, all of the energy being supplied is going to be immediately dissipated by the circuit. So we got to start somewhere. You're not here to pick for me, so I get to pick which element we start with. It doesn't matter. Just pick one and go with it. So why don't we start with the resistors? I think they're the most obvious. I think they're a little easier than the sources because they are passive elements. So we know that they're passive right off the bat. Okay, so I'm going to start with the 4-volt resistor. So let's see if we can, they don't have names. It would be easier if they had names, right? So let's start with the resistors and our 4-volt resistor over here. So I'm going to look at the power being dissipated by that 4-volt resistor. I'll call it P sub 4V. I suppose that identifies it sufficiently. And I'm going to take the voltage, no matter what it is. Okay, and then I'm going to look at the current direction. So the positive going current direction, based off of the voltage, is left to right. Hopefully you knew that already. It's left to right, so this current is going in the positive direction. That's positive 1. Okay, so we're going to multiply that by positive 1 amp, and I can do that one in my head. Stand back, folks. That is positive 4 watts. Okay, so the fact that it's positive tells me that it is dissipating 4 watts of power. Okay, so that's the first one there. Let's take the 12 volt. I think that's going to be kind of a similar type of thing here. Think about the positive current direction while I'm talking here. What's the positive current direction for the 12 volts? Okay, I'm going to take that 12 volts. I'm not going to take any sign with it. And now I'm going to come over here and say, well, positives here, negatives here. The positive current direction is going to go down. I see 1.5 amps flowing down. Okay, so once again, it's going to be positive, and it's going to be positive 1.5 amps. Okay, 12 times 1.5 is plus 18 watts. Okay, so between those two elements, we have 22 watts being dissipated in this circuit. All right, last one. We're going to come over here, and oh boy, we got tricky on you, didn't we? We got tricky. We got some negative signs. We got the arrow going in the other direction. All sorts of craziness. It's going to work out if you kind of just procedurally walk through this. So this is going to be the negative 3-volt resistor. I want to know the power being dissipated by the negative 3-volt resistor. Okay, I take the voltage. I don't think about sign. I just take the voltage, whatever it's labeled. In this case, it's labeled negative, and we're going to take that negative sign this time. Okay, it's not that it's always positive. You take whatever is labeled. That's labeled 4, that's labeled 12. According to this polarity, it's negative 3. Okay, so I take that negative 3 here. Okay, the positive current direction for that polarity is left to right. Okay, and since it's left to right, and I'm looking at this current, and that current's going opposite the positive current direction, I'm going to take that to be negative 0.5 amps. Okay, negative 3 volts times negative 0.5 amps is going to be positive 1.5 watts. Okay, and that's what we would expect in all of these cases. Is that these are resistors? They're passive elements. They better be dissipating power. They really have no way to supply power. If you can make a resistor supply power, write me an email. We'll talk about it. We will patent that, and we will get out of here. Okay, no more of these videos. Free energy. We're getting out of here. I would love that. So figure that out for me. Yeah, it's not going to happen. Okay, I would love it. Okay, so those are the three resistors. We got to go do the three sources. Okay, the 3 amp, the 2 amp, and the negative 1.5 amp. And we're going to play a similar game. Okay, our sources. What's going on with our sources? So let's start with this 3 amp down here. And we're going to say the power dissipated by the 3 amp. I'm going to take whatever the voltage is. It's labeled as 16 volts. Okay. The positive current direction would be down according to that 16 volts. But I see the 3 amps is going up. So it's going to be negative. Okay. Negative 3 amps. So what is that going to be? 48. Negative 48. Right? Negative 48 watts. Okay, and we kind of expect that. That source is supplying 48 watts. Well, let's see, that's 22. Another watt and a half, 23 and a half. So that's supplying more power. So something else must be dissipating power that we're not anticipating. Okay, so let's go look at our other supplies. And we get the power dissipated by the 2 amp. Okay, it looks like there's 1 volt. We'll take that at face value. The positive current direction is left to right. Oh, and look, it's going left to right. So that's positive again. So we get 2 amps in that case. Okay, add those together and we get positive 2 watts. So we've got a source that's dissipating 2 watts. And that can happen. If that source needs to dissipate 2 watts to make 2 amps flow in the direction indicated, and that's what that source is going to do. It will adjust its voltage accordingly to regulate to 2 amps. Okay, let's do one more. I think we still have more power to burn here. So hopefully we're going to find it when we consider what's going on with the negative 1.5 amp supply. And we take the 15 volt at face value. Oh, this one gets super crazy. The positive current direction is going down, so we get a negative sign from the fact that the current's going up, but then we also get another negative sign. Oh boy, just to make it super confusing. Okay, this one's from the current direction. Okay, and this one is from the labeled value. Labeled value. Okay, so negative 1.5. All right, so we get 15 volts. This is going to end up being positive times 1.5, and that's going to end up giving us positive 22.5 watts. Okay, so we are dissipating. So these two supplies are dissipating power. And we wouldn't know that if we made the naive assumption that it's a current source. It must be supplying power, but it's not because of what's going on around it in the circuit. Okay, if we're conserving power, I should be able to add these up. Okay, these are the values that I'm interested in. Those are the 6 power dissipations for the circuit. Okay, so let's look at that, and that. Now, if we add those all up, right, plus 4 watts, plus 18 watts, plus 1.5 watts, minus 48 watts. I'm not done yet. Keep going, brain. Plus 2 watts, plus 22.5 watts. Okay. I'm going to pause the video. Oh, it's all behind my head. Woo! There we go. That looks better up there. It's good stuff. Did my forehead disappear? Green screen's tweaking it in still. Okay, I'm going to pause the video. I'm going to add those up. Maybe you've done it already. I don't trust my brain to do that stuff in my head, but it should come out to 0. Okay, so go ahead, add those up to 0, and we can show that we're conserving energy. Okay, it works out, right? So the net power being dissipated by the circuit is 0 watts, and that's how we know we're conserving energy. That 48 watts is the only thing being supplied. It's dissipated by all of the other components in the circuit. All right, so I wanted to show that, well, the circuit has to obey conservation of energy, and I also wanted to go through a lot of examples of using the passive sign convention when calculating power dissipation by both passive and active elements. Okay, so you got some web work questions. Stay tuned and good luck.